So these are the same things that we have done before. So I will be hitting this concept again, and again until you will become expert in Wireshark. Because if I will dedicate one lecture just for the Wireshark, you will be confused. So this is how I'm handling, this scenario by scenario. So you are familiar at this point of time. Means what is this? Can you tell me, Crystal?
That are the connection to your host.
Yes, the network interface card basically.
Oh, okay.
What of course my PC, let's suppose, have multiple network interface cards, and I want to run or do a packet analysis just on this network interface card. So this is how I'm going to see these all network interface cards here in a sequence. So I can select this particular network interface card to do the deep packet analysis just for that network interface card.
Question, and I'm sure that the answer is very simple, but you can also, like when we were doing this, when I was doing the simulation for the panels, can you do the same? The panels also have network interface cards. Can you do the same?
Sorry, I didn't get what do you mean by panels?
The IDF and the MDF, you know how it has like the servers?
Okay.
Can you do the same for the network interface cards on that?
Yes. Okay. If you're talking about these MDF, IDF, those are just nothing but just, the infrastructure, how your, the infrastructure will be look like, where MDF and where we have the IDF.
Oh,
basically,
I mean,
it's nothing that just the distributions.
No, I mean,
okay, you want to analyze. Okay, I got your
the server
idea.
inside.
Okay, yeah. I think I have already discussed these things in our earlier slides. Basically, we have, let's suppose, the switch here. Okay, and let's suppose this switch has only 4 ports.
Cameron, if you explained it and I missed it, then I can just go back and watch it. You don't have to re-explain it, please.
No. I will just explain it. If you are familiar with the span and RSpan, I discussed this in my day module 1, session 1.
Yes.
You still remember? If you can answer this, this is your answer of the question. You remember span, RSpan we discussed about?
I remember discussing it, but I can't remember exactly.
Okay, the span is if we have this one switch, okay, and we have one host machine here.
Oh, it's for monitoring traffic, right?
Yes, monitoring traffic.
Yes.
Yeah, exactly. The opposite of span is RSpan, where lies the answer of your question. So this is remote span. You are talking about, let's say, the IT closet. You are sitting somewhere, you are sitting in another office, while your office closet is somewhere else, okay? And you want to do analysis, okay, somewhere in that switch.
Yes. Sorry,
so
I asked the same question.
No problem. This is how you are going to learn. If you're not asked, you are not going to learn anything. So this is the concept of RSpan. You will enable RSpan on this switch, okay? And this may, let's say we have multiple switches in between, but you are only interested in that port. So you will enable RSpan feature, and then you will run your Wireshark on this computer. And this is how this RSpan is going to send all these packets to your Wireshark machine.
Yeah, and another thing is that, Haifa, this is something that when you get into more of like a monitoring and security lectures, and this is where we're gonna touch that more, but just to quickly answer your questions, most of the companies will have something like that set up. They're not going to have like one simple Wireshark machine with a few network cards and just capture traffic from that, right? If they want to capture their whole network or what's going on, they're going to have something like that where all these packets are generating and it's going to a specific design port for that purpose. So they may have Splunk on that. They may have some other monitoring tools on that, or anything that will actually capture all the packets. It's going to go like thousands of packets are going to go to that port, and it's just designed for that. And it will have a lot of space. That server will have a lot of space. So then they will do all this analysis and everything.
Yeah.
Understood. Thank you.
So in Windows environment, we usually use packet tracer. This Wireshark. But in the Linux, we have built-in feature. If anyone can tell me.
I'm sorry, can you ask your question again?
In Windows, usually we are using Wireshark. It's a third-party software to analyze the packets. Then we have another machine, which is Linux. Can anyone tell me what Linux is using for capturing the packets?
No, in Pakistan they use Linux, but here maybe that's why you're getting confused.
Linux. No, I understand.
Okay.
I didn't hear the question the first time. No, you're fine. Linux.
Okay, that's fine. This is called TCP dump, just for your information.
Kamran, this is a joke. We have a member in our Discord community. He's our friend. His name is FDS. So I think we're gonna have to call him right now.
Yeah, okay. He's the Linux expert.
Wow, great. So I was pronouncing right this because I was saying Linux.
I think they pronounce it the same way in Saudi, but it's Linux. I mean, that's Linux. How we say it.
Okay, that's fine. Thank you for the correction.
I have a quick question.
Yeah.
So it's about span. I want to be sure span is different from spanning tree, right?
Yes. This is very confusing. You asked a very good question. Span has to do with the monitoring, while spanning tree STP has to do with avoiding the loops.
Okay, thank you. I just wanted to be sure that it's different. Okay.
Yes, and your next module is just all about these things. Okay, so we are here and I just want to capture my local area connection. So I will just double click and you will see it start capturing the packet. And behind the scene, I'm doing nothing but just, some Zoom session is going on, some one web session is going on, and you can see so far we have reached how many packets. So I'm just going to stop because I just want to show you how the IPv4 header looks like. So just select anyone, let's say TCP. So I guess you are wise enough at this point. You can tell me in these 1, 2, 3, which one belongs to IPv4 or IPv4 header?
The middle one, the one that says Internet Protocol version 4.
This one?
Oh, the header?
Yeah, IPv4 header. If I want to know information.
No, then the first one, sorry.
This one?
Now I'm confused.
This okay, come
the
again.
Ethernet one.
Tell me. I'm talking about IPv4. That's it. Which layer should I need to go into?
My guess is the one that says Internet Protocol version 4. I'll stick with my guns. Yes. Okay.
How about Crystal?
Yeah, I would choose the same.
Okay, you are correct. Because it is written here, right? Internet Protocol version 4.
No, I know, but the way you said this one, I was like, maybe not that one.
Okay, that's fine, no problem. I just want to make you confused.
Good job. You did it.
Okay, so we will go into the detail of this IPv4 header, and we are not going to touch Ethernet 2 and transmit because if you remember, we have already discussed about these two layers. So I'm just focusing on IPv4. So if I want to correlate with this one, can you see this slide as well?
Yes.
Yep.
Okay.
Yes.
So this is IPv4 header, and it is talking about the version, and we have already gone through what is the version, and you can clearly see here it's saying this is IPv4 version. In a binary notation, it is look like this: 0, 1, 0, 0. Why? If I do a bit notation, 1, 2, 4, 8. So the fourth bit, this third bit is on, which is saying this is V4. Okay, because we have the 4-bit notation here. Opposed to IPv4, we could have the situation like this. We could have, and I'm going to ask you, what is it representing? So instead of this, if I have this thing 0, 1, 1, 0, what does it mean?
You mean in this decimal?
This is the binary. Have you gone through the binaries, by the way?
Yes.
Okay, that's fine.
I was asking, I don't understand the question.
The question is for the bit notation for IPv4.
Ah, okay.
Okay. I find out that on my third bit, which is representing 4, the bit is on. It means I am on IPv4.
Mhm.
If these 2 bits are on, this is representing what?
6.
And what does it mean?
IPv6.
Yes, exactly. Okay, then we have header length. We talked about the header length here, IHL. Then what we have, type of service. If you want to correlate this one here, you can see this is the thing. This is also known as differentiated service field, DSC. These are the things I am talking about: the quality of service in routing, class of service in the switching, when we want to prioritize our network traffic, like the voice over IP and these things. Then I have a packet length, which is the information of the payload, which is total length is 40. So currently this is the packet length of my packet or the payload. Then I have these fields: identification, flag, and fragment offset. You can see these things here. Sorry, I hit wrong. Okay, then we have time to live. Currently it's set to 128. Then it is gonna decrease as it will move on. Then it is showing what? TCP. So it is using TCP. It has to do with the protocol, what I was talking about earlier, the protocol. Either it could be TCP or UDP. If it is using TCP, it means it is heading to HTTP traffic, HTTPS traffic, or any reliable traffic. But opposed to this, and you have to always remember this, TCP use the port number, the protocol number, not port number, sorry. This is the protocol number, which is 6. This is also a very good interview question. They can ask you what protocol number TCP is used. And you know, in the end of this, the whole section, I'm going to give you the well-known ports information. I will share that, so you can just memorize those. So as opposed to the TCP, let's say if I select the UDP, and you can see UDP is using what protocol number? It is 17. So if it is 6 here, I'm talking about TCP, the reliability. If there is 17, let's suppose this is hidden, UDP is thing hidden here, and you have only this thing. And why you need to remember these ports, protocol numbers? Because in a firewall, firewall is not very helpful. They give you the information about whether it is UDP or TCP. It will just give you information. This is 17. It is 6. It is 8080. It is 443. So you have to remember this, what this correlate to, which is HTTPS, what this correlate to, which is UDP, and this is TCP. So you have to remember these things. Okay, then we have these header checksum. I told you the validation is disabled here. Just a minute. Okay, so these are the header checksum. Then we have last but not least, source and destinations. As you can see, the source address and the destination address. So at this time of point, if this is the reply is coming, you can, because if you know what is the IP of your host machine, which is my 192.168.100.3, this is my PC. As you can see, this is the destination. It's mentioned. Destination is 192.168.100.3, and the source is this thing. This is my request, which is originating from my host machine. So this is also a very quick identification.
Super important to look at it and say, okay, that is because when you start troubleshooting, you don't go all the way down and come around, you get corrected. You don't go all the way down to the last packet. You actually go all the way up to the kind of like the starting packet, and it's gonna be a different story. Then you will see you as a kind of like a requester, as a source, and you have to then find that destination. Where did it hit?
Exactly.
Did I got blocked from there? What kind of reply did I get? And that's where most of your calls as a network engineer relies in that area, where then you have to go all the way. What happened 10 minutes ago? Before someone called, you say, okay, we are having this issue. We're not going to jump into the packets that's going to happen at that time. We're going to jump into the packets that's going to happen 1 hour before, or whenever that we feel like, okay, that is like the starting point of this issue. And that's where you're going to find out that, okay, I have hit some other IP addresses in the beginning, and now I'm seeing in a reply, I'm seeing a total different response. So to save your time, you will have to go a little bit earlier in that time in any troubleshooting cases.
Yes. And in network, usually if you find, if you come across with the delay issues, the packet tracer is the #1 tool. You can check the delay, why there is a delay happening. Okay, so that is like beyond the concepts, but you must have some idea. What is the reason we are using Wireshark at first place? Okay, so I hope the concept is clear.